All right, if you haven't watched the previous question, please start with that. It says, what is the molar mass of an unknown compound when 18.2 grams are dissolved to make 1.8 liters of solution with an osmotic pressure of 2.33 atmospheres at 25 degrees C? And then it gives us the dissolution equation so that we can know the Van Hoff factor is 3 because we have an x plus and two y minuses, so 1, 2, 3 things, so I is equal to 3. So from the previous question, we went over that the osmotic pressure equals I times C, the concentration, times R, T, and how this is just a derivative of the ideal gas law, where moles and liters are in concentration. Okay, so that's basically that. But in this case, we actually wanted to solve for the concentration, because if we can find concentration, then we can find moles. It asks us for the molar mass, and molar mass is grams divided by moles. So we want to find this molar mass. The grams are easy because the grams are given in the problem. The moles are much more challenging, but the moles can be found by finding the concentration. If we take the concentration, which is in moles per liter, and we multiply by the number of liters, then we can find the number of moles, and take grams divided by moles, we'll find our molar mass. So first thing I want to do is rearrange this equation to solve for C. And when I do that, by dividing by IRT, I find that C equals pi over IRT. So we basically just took this, divided by IRT on both sides, they all cancel, and I move that over. So if I take a look at this, okay, the osmotic pressure is given, and it's given in the right units, so I can put in 2.33 atmospheres. I, we figured out because we're given the equation, 3. R 0.08206, that's liter atmospheres per mole K. I wrote that out in the previous question. And then the temperature has to be in Kelvin. So I can't plug in 25, I have to plug in 298 K. And when I do that, I find that this solution is 0.0317 molar. Okay, so it's 0.0317 molar solution. Now I need to find how many moles. Well, if it's 0.0317 moles per liter, if I take 0.0317 moles per liter and I multiply it by 1.81 liters, the liters cancel, and I find that there's 0.0575 moles of this unknown compound in it. So I take the molarity, I multiply by the liters, I find the moles. Now I can finally find molar mass, because molar mass is the grams per mole. So the molar mass is the gram, given in the problem, 18.2 grams, divided by the moles, given that we just found, 0.0575 moles. And when I do that math, I find that the molar mass is 317 grams per mole. So this is the molar mass of my compound. So this is just a rearrangement of the question in the previous question in order to determine molar mass.